Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following trigonometry in triangle revision question. We have in triangle ABC, the line AB is equal to the line AC and AB is equal to X. The angle A is equal to 2 theta. We are to 1. Determine an expression for angle C in terms of theta. Simplify fully. 2. Determine an expression for BC in terms of x and theta. And the last part of the question says if theta equals 20 degrees and x equals 15 centimeters, calculate the area of triangle ABC. I'll start with the first part of the question that says determine an expression for C in terms of theta. You can see that from the diagram, the line AB is equal to AC, and that was also stated in the question. So therefore, we can say that I'm solving this question 7.1.1, the angle B is equal to the angle C, and the reason being base angles of isosceles triangle ABC. So therefore, if B is equal to C, I can pick one and state that C plus C, because that's equal to B, plus angle at A equals 180 degrees. The reason means sum of angles in a triangle add up to 180 degrees. So therefore, 2C plus angle at A, that's 2 theta, equals 180 degrees. Using the balance method, I have 2C equals 180 degrees minus 2 theta, and dividing both sides by C, I have C equals 180 degrees minus 2 theta divided by 2. So therefore, the angle at C equals 180 divided by 2, that's 90 degrees, minus 2 theta divided by 2, that's theta. So therefore, you can say this angle is 90 minus theta, and this angle is also 90 minus theta. The second part of the question says, hence, determine an expression for the line BC in terms of x and theta. For this question, I can either use my sine rule or my cos rule. So I'm going to show you the two methods. Hopefully we get the same answer. So if I'm to use my sine rule, the sine rule states that the ratio of the side BC over the sine of the angle facing BC, that's 2 theta, equals to the ratio of, pick any of the two sides, you can say AB equals to the sine of the angle facing AB, 90 minus theta. Therefore, from here I have BC equals AB, that's x. So I have x sine 2 theta divided by sine of 90 degrees minus theta. And if I simplify further, that is going to give me x sine 2 theta. I'm going to use my double angle identity, so that is going to be times 2 sine theta cos theta. What I'm doing is I'm expanding my sine 2 theta using my identity, and I have that as, then if you look at my denominator, that's a cofunction for sine and cosine. So it's sine 90 minus theta will give me cos theta. And if I simplify, I have cos theta, cancelling cos theta. Therefore, the line BC is equal to 2x sine theta. Now I'm going to do the same using my cosine rule. That's the second method. cosine rule. Cosine rule states that using the side BC as my reference side, and that will be the angle facing my BC will be my reference angle. I start with BC squared equals the side AB squared plus AC squared minus 2 times AB times AC cos of the angle facing my line BC. That's cos 2 theta. Therefore, simplifying, I have that as, because this is equal, this is also x. So I have x squared plus x squared minus 2x squared, because that is x times x. Then I have that as cos 2 theta. Therefore, that is going to be equal to 2x squared minus 2x squared cos 2 theta. I'm going to factor out 2x squared. I'm left with 1 minus cos 2 theta. If I simplify further, I'm going to use my identity for double angle for cos 2 theta. So I have that as 2x squared in bracket 1 minus, I'll put that in a big bracket, cos 2 theta. I'm going to use the identity 1 minus 2 sine squared theta close bracket. This is going to be 2x squared in bracket 1 minus 1 plus 2 sine squared theta. That's 2x squared in bracket 2 sine squared theta, which is equal to, that's 4x squared sine squared theta. That's my BC squared. And because I'm to find the line BC, I'll find the square root of both sides. So therefore my BC equals 2x sine theta. And you can see that I have the same value if I'm using my sine rule, which is simpler, and then the same value if I use my cosine rule. Let's go back to the third part of the question that says, if theta equals 20 degrees and x equals 15 centimeter, calculate the area of triangle ABC. So I'm going to draw out my triangle. That's ABC. Please don't forget to click on the like and subscribe button for more easy to understand math concepts. So therefore, I have the side. I'm going to take out A, B, and C. My x is equal to this side, and that's 15 centimeters. 15 centimeters. And I've been told that theta is 20. So that will be, this is angle 40 degrees. And then the other two angles will be 70 degrees. So therefore, using the area of the triangle, so I have area equals of AB sine of the angle being subtended by the side AB. So that's going to be sine C. But in this case, I'm going to change the variables I'm using because I want to use the side x and x, that's AB and AC. So I'll change that to half of AB times the side AC, the sine of the angle subtended, that's 40 degrees. So that's going to be half times 15 centimeters times sine of angle 40 degrees. And that's equal to 71.31 square centimeters. Thanks for watching. Bye.